Welcome back, everybody. In this video, we're going to be taking a look at playing around with a little bit of BGP when it comes to ASA and iOS, excuse me there. So we're going to do a BGP peering, a real basic one. And then from there, it's really not much more to routing than that. There's obviously some authentication and stuff like that we'll be covering later on down the road. I don't really want to deal with that too much right now because it's really, if you know how to do it in iOS, doing it in ASA is pretty much the exact same thing. It's just going through the motions of setting it up on ASA. So I'm going to go through the process of setting up the BGP peering, and I'm going to turn off the OSPF peering between the router and the ASA. So this peering right here is going to go away for OSPF, and then I'm going to replace it with BGP peering. And then R1 is going to do a default information originate towards ASA1, and ASA1 will get the route, and then we'll be able to take and redistribute from BGP into EIGRP and go from there. So we might have to do a little bit of manipulation up here in the routing just to get the end-to-end connectivity in place. We'll cover that, come to that when we get there. And so yeah. It's actually kind of funny. One of the very first videos I did for this security section, somebody asked me if I was doing a green screen, and I am doing a green screen. As a matter of fact, just to prove to you it's doing it, that's a can of Mountain Dew. Now, what's cool about it is if I turn it around, the can pretty much disappears, which tells you that I have a green screen, which is pretty cool. So yeah, I can come and go. Whoop. Wrong window. I can come and go out of it as I please, which is kind of cool. And if anybody's curious, I am using OBS as the recording platform. So pretty much the videos are pretty much raw. The way that I record them is the way that I upload them. So with that being said, let's go ahead and begin diving into this whole monotony and get that done. Because once we're done with this, then we have some follow-on stuff with ASA that we're going to be doing and going from there. So, as a matter of fact, our next video we're going to be taking a look at, dialing in. We've already covered this, but I'm going to go through a breakdown to the ASDM and how that comes into play. And then we're going to take it, then we're going to start getting into the more of the meat and potatoes of how ASA operates. So, with that being said, let's dive in. So on the routers, so I'm going to go ahead and I'm going to bring this down just a touch and bring this up just a touch. You should be able to, there we go. So on R1, and what we're going to be doing is we have R1 who's going to form a BGP peering with ASA V1. So on R1, I'm actually going to go ahead and show run section OSPF and show run interface gig 0/0. So I'm going to go ahead and do this. No IP OSPF 1 area 0. So that's going to remove OSPF from the adjacency with ASA V1. And what I'm going to go ahead and do now is have a router BGP 1, and I'm going to specify a neighbor statement. So I'm not going to get into a deep dive about how BGP works in this video. I'm just not going to do that. What I will do is no BGP default IPv4. I will type in neighbor of 10.1.10.10 remote AS of 100. And then I'm going to specify that the address family IPv4, and I'm going to activate the adjacency, and then I'm going to go and do a default information originate, and do that. So do show IP route. I'm going to go ahead and underneath the address family, I'm actually going to go ahead and redistribute OSPF 1, but I'm going to match on the external route and the internal route. I have to do that in BGP because by default on iOS, if you have OSPF and BGP running in the same router, and you're learning the OSPF route, the external, the default route through OSPF, and it's an external route, BGP won't pick that up. So you actually have to match the external route in order for that to pull it in. And I also want to match an internal, so I want to be able to grab everything that is coming in and be able to point it out. So now if I type in, I haven't advertised anything yet. So all I'm going to be doing is if I come out and do a show BG or show BGP, all we're going to be getting is the local routes. So if I do a show IP route, it should be matching on that, but we're going to be originating a default route anyway. So we're going to go ahead and we'll fix any issues that we run into. So on ASA 1, I'm going to go to no router BGP 1. I'm going to type in router BGP 100. Now there is, I don't believe there's a no BGP default. Okay, yeah, that's what I thought. So because the ASA it's been extended to support these capabilities, because there's times where you might be working with a provider and you might do BGP, but it's not likely that your ASA is going to be doing a whole lot of routing. Most of the time people are just going to plunk in an ASA and just throw a default route out the internet. So we'll talk about how that comes into play in just a minute. Once I'm done, I'll kind of highlight what the provider is doing in order for that to work. So I'm going to type in neighbor. Do I have to do BGP? Let's see here. Oh, I have to go to address family. Address family, IPv4 unicast. Sorry, I don't want to blow your eardrums out when I cough. So I'll type in neighbor of 10.1.10.1 remote AS of 1. And then that should be all I need to type in, unless there's the activate. Is the activate command there? It is. Okay, activate. Cool. Activate, and we'll do that. Now, this should form a BGP peering. So show BGP or show BGP summary. And I have a peering. If I do a show BGP, I have 2 routes. Now, when we look at this, the on R1, so we should actually be receiving a default route as well. So my peering is up, show BGP. So and there's the default route. The default route has been learned. It just took a minute for it to propagate, and so ASA 1 should be learning that now it is. So that I was actually a little worried about that at first, but it did clear itself up. So now if I look at now this is the BGP table. This is not the routing table. So again, you have the first step is the adjacency or the peering, and the second step is building the neighbored, the topology table or your database of all the routes you're going to know about, and then you run your best path selection over those routes. Then once those best path routes have been determined, then you inject them into the routing table. So if we type in show route, we are learning a BGP default route, and the reason why it's going the BGP route is going to win over all the other routes is because of the fact it's got a lower administrative distance. I knew that coming into this, but here's the caveat. That stops at the ASA. It does not propagate down. We actually have to redistribute. BGP into EIGRP in order for this to work. So I actually have to go into router EIGRP1 and type in redistribute BGP and then the AS number, and I have to specify the metric. So the metric here is going to be the same, pretty much the same values as I laid out in the previous video. So now that I've done that, I should be able to go back to test 9 and look in here and do a show IP route, and we should have a default route from 7 seconds ago, which we did learn, which is exactly what we want to have. And that's really it. If we ping 8.8, I should be able to ping Google momentarily. So let's do this. Ping 10.255.1.1. Okay, so here's part of the problem. So when we have the peering with R1, right? We do a show IP route. We're getting a default route from there, right? But this default route is not being sent down. So if I was to go back to R1, I'm sorry, test 9. If I was to do a trace route to 10.255.1.1 numerically, which means I don't do any DNS lookups, and I go, it's gonna start timing out, even though show IP route, even though there's a default route. It's kind of a weird issue. It technically should not do that, but it's doing it anyway, which is a little, it's tricky to troubleshoot. Let me put it to you that way. So, but if we pull up the same concept should be applied here for the server. If we try to ping Google via Quad 8, it's not going to work, right? If we do a Control C and then we do a tracert to -D to 8.8.8.8, it should point itself towards the ASA. And unfortunately, when we do this, Control C that, we go back to the routing table on the ASA and we do a show route. We look, there is a default route. Now if we try to ping, we see the BGP route via 10.255.1. So if we ping 10.255.1.1, it doesn't work. Now why is that not working? The problem is you have to check the remote end has to also have connectivity to you as well. So if we go to router 1 and I ping 10.255.1.1, it works. So if I look at router BGP, the problem is it's not, the redistribution that we're doing is not mutual. If we do a show run section BGP, notice that we're redistributing OSPF into BGP. So we're taking OSPF learned routes and bringing them into BGP. But if we look at show run section OSPF, we are not. All we are doing here is forming an OSPF adjacency. So if we were to go a step further, let me go ahead and pull up my, is this my home router? No. Go and close that out. Log into that real quick. So if we were to look at my routing table on my router, you're going to see that there are, I see 10.255, I see 10.1.1, I don't see 172.16, I don't see 10.1.100, 10.100.10, 10.100.20. I don't see any of those. So if we look on here, router, if we look on router 1 and we do a show IP route, we are missing the 10.100, the 10.100 period, and 172. If we take that a step north to the ASA, if we do we got those routes learned here though. So what do we need to do in order to fix this? Any ideas? Well, the simple thing would be to do this. Show run router BGP. The simple thing would be to take and advertise those routes into BGP, so those routes on ASA 1 are propagated to router 1. Router 1 would then learn them and then propagate, and because they're doing mutual redistribution, at least they should be. I don't think I am. No, I am not. I'm not redistributing BGP into OSPF. So that's the first thing I need to do. I'm going to type in router OSPF 1. I type in redistribute BGP 1 and then subnets. So that's part of the problem. So now if I go to my home router and I look at this again, I hit the up arrow, I'm still not learning any of those routes. So what do I need to do? I need to go back on ASA 1 and I need to go to global config and I type in router BGP 100 and type in network of, or address family IPv4, network of, and say 10.100.0.0 with a mask of /24. actually .10, .20, and then network of 172.16.30.0 with a mask of /24. So now when I do a do show BGP, or show BGP, I have those routes advertised. I go to router 1. I have 10.100 now, and it's going to take a moment. So in order to speed this process up, I'll type in clear BGP star soft outbound, which is going to do a triggered update. I go to router 1. I hit the up arrow. Now I have those routes in the routing table. I come up here on here. I do a show IP route, and notice I have these external routes. I have the 10.110, 10.120, and then I have the 172.16.30. So now if I go back to this and I do the trace route, give it a moment to figure itself out, it should start to work. Let's go to test 9. It gets there all day long. So it gets out to that. Let me go to, and I can ping Google. So I'm not sure. Oh, I see what the problem. And I can ping Google again. And that's the point here. So let's actually go and do this. Let's do a trace to google.com. And because it can do name lookup, it's going to. So the very first ping is going to get dropped. But trace on this particular platform is actually not going to work. You might say, well, how come? Because of the fact it's an ASA and the traffic that's going out is not the same traffic that's coming back in. Okay? So to solve this problem, we actually have to do a little bit of ACL filtering, and I have to do this on the ASA. So, because I've gotten this question before. So let me show you a couple things that you can do. So let's do a show run policy map. And there is a couple of things that we can do. So there are, let me do a quick show run completely here. Show run and see where it's at. Because I don't do it very often, but there is a way to fix that. I just have to find the, is it this one? I think it might be this one. Let me go to this guy here and say class map inspection default, and no, it's where is what I'm looking for? There's a way to, I might have to do a show run all the way at the bottom. Let me just go to the bottom. Okay, so now if we scroll back up a little bit, so this is the default policy. You see the inspection default, and there's the default inspection traffic. Two different class maps. I'm trying to think of where this one gets mapped. Global policy, global. Let's see here. Let me find that real quick. I'm not 100% sure where off the top of my head this is actually mapped to. So it's class inspection default. Class map, match default inspection traffic. Let's see. Let me actually just grab this command right here, because that's got to match something. Let's do a show run pipe include and see where that's just that one. Okay. So let me go, and I believe it is, I think I might be able to do it here. Let me just check. Set connection. Yeah, that's the connection. Oh yeah, here it is. Okay, this is where it was. I wasn't sure. The decrement TTL command. This is where you can decrement the TTL, and do that. Now it says only inspect action is allowed. So if you want to do, so it says is allowed for this class with matched default inspection traffic. So if we do a show run service policy, service-policy, we'll see that this is the service policy global is deployed, and that that's actually the let's do a show run class map. Trying to think of how to access that. Oh, and there it worked. As soon as I got that as soon as I put that in, it started to work. Just kind of funny how it waited to the very end. So the very first hop should not come back because that's the ASA. But and once we get past the ASA, we're in router territory. So it's all routers. So that's going to fail too. So I'm going to let that bug out. So let me see here if I can't find. I want to say that's the default inspection traffic. I want to say that is a class map, class-map, default inspection traffic, match. See, this is going to match on stuff. I don't want to match on anything. Wait, default inspection traffic. I don't want to match on anything. I want to set a variable. Now, there is a way to do this otherwise. And the way that you would do this is create an access list. And so that what you would do is you would say access list, and you would call it ACL trace route, and then you would say extended, and then in your logic you would say permit ICMP, and you would say ICMP from any source to any destination, as long as it is a time exceeded, as well as a unreachable. And for good measure, I will say trace route. And then with this, we do show access list. That's the ACL. And then what you would do is you would type in access group, and you would say the name of the access list is going to be ACL trace route. And you say in on the interface outside. Now that's what it should do, right? And if we do show access list and we try to do that trace route again on this guy, notice how it replies with that information. So if we hit trying to get over to we'll see that there's hits on the time exceeded and the unreachable. It needs those values to come back in because it's going out one method, coming back in another. So we need to have that capability built into, and so all that good stuff that goes along with it. So if we were to go to test 9 again and do a trace out to Google numerically, we'd be able to do that as well. What you won't see in the trace route is you won't see the ASA is showing up. So 10.1. The ASA is not showing up. So the ASA does not show up in the trace, which is an indication that it's not decrementing its TTL value. So there is a way to do that. Let me just go do a quick Google check. Decrement TTL on the ASA. So there's a way of doing this, and I forget the actual command to do it. You have to excuse me on that one. Oh, that's right. Okay, so on the ASA, it's one of those things where once I realize what the problem is, you type in do show run policy map, but at the very bottom there is no class-default. So we have to type in underneath this guy right here. We type in under here, we say class-default, and under here we set the connection decrement TTL, and we hit the enter key. Okay, so what that should do is now when we do a trace route on, say, test 9, you should see the ASA show up. And you do. The ASA 10.100.10.1 now shows up. And that's what you should see. The same thing applies here. If I was to do this trace route again, trace to Google, you would see, and it's actually kind of funny that we're getting differentiating results when we do that. But that's basically how that would come into play. So request timed out. So, and I wonder if the access list is going to be triggered now too. Show access list. Yeah, it's still triggering on both the time exceeded and the unreachable. So both of those are both getting triggered. Okay, so finally starting to show up. So yeah, that's just basically how it comes into play. I forgot about that default ACL, or the class-default class. So I'm just going to go ahead and close that out. So that's pretty much what I wanted you guys to be able to see when it came to how to manipulate things. And that's just how the ASA works. Routers don't do that because they're classless. And if I check on the ASA and do a show con long, you're going to see a lot of these UDP messages going out. So you're going to see a UDP outbound and then an ICMP return. Because that's what it is. It's the unreachable. So basically what's happening is the ASA is sending a UDP message outbound. The ASA sees that and opens up the connection. But what ends up happening is an ICMP comes back in. And when the connection table is checked, if we were to remove that ACL, so let's do a show run access group, and go to global config and type in no this, and then do a logging enable, and then we were to try to do that same thing again. Let's go to test 9 and try to do that trace route. It's gonna it's kind of weird. All of a sudden now let's see if that has any effect on it. Oh, I wonder if the ACL had something to do with that. But it's decrementing the TTL now. But I wonder if it's going to block. So what should be happening, or on ASA. Now you'll see, okay, so this is what I wanted you guys to see. What it's going to do now is it's going to, if you look right up here, you see all these UDP messages and stuff like that. It's going to start tearing them down. Let's see, scroll up here a little bit. What I was expecting to see was a bunch of deny inbound on the outside interface. Yeah, see right here, this deny ICMP source right here, this guy right here. This is what I'm expecting to see. Because what's actually happening is it's coming back in as ICMP. It's as you can tell right up here, is it's sending UDP out, right? If I was to come over here and do a Control C, if I was to come up here and look at this, it's sending out a UDP message. So it's tear down UDP connection going outbound. That's what it's doing. So it's sending a UDP out, but you see all these ICMP messages being denied. That means that the ICMP is coming back in. So UDP out, ICMP back in, and unless you explicitly permit that, it's going to die. So let's go ahead and let's continue to do that trace route to Google, and we'll do that on that. But then we'll go up to, we'll hit the up arrow and we'll say, instead of the no access group, it's going by so fast I can't catch it. Actually, let's do this. No logging enable. Let's do Let me just grab this real quick. In interface. The only thing drawback about doing it this way, TRAC, trace right in. So all of a sudden now you'll see on this guy right here, you'll start to see the pop up because we're allowing the connections to go out. So we do logging enable, you're going to start to see those messages start popping up. You'll see a UDP out and an ICMP back in. So you can see build inbound ICMP connection for those public IPs. And that's what you see. If you're permitting them in, then they'll be allowed to come back in. But you got to remember it's UDP out, ICMP back in. And because there's a connection table that they're going through, that's the reason why that happens. So, so that's that. Now, if I was to go to, let's go ahead and just cancel that out because I don't need it to go over and over and over again. The last thing I want to talk to you real quick about is how the provider would do things if all you were doing was getting a circuit delivered to your location and you wanted to create a default route. And you didn't want to do any routing. You're like, I don't care about it. I don't need it. Very, very common for small branch offices that run BGP, or even really big companies that I've worked with that have deployed an ASA on the edge, and they're like, well, can't we just do a default route? Because they've asked, well, what are my options? And I go, well, you could do BGP, you could do, just a default route. It really is up to you. Because what's going to end up happening is, go ahead and grab my pen pad out real quick and draw this out real quick, is what's going to end up happening is if there might be no BGP here. So if we type in no BGP here, that's very common to not run BGP. Normally you're going to run BGP in a situation like this over here where you have MPLS running. We're going to be covering that in a lot of detail once we get into the VPN section, which is going to be coming probably sooner than I expect because I'm flying through the security stuff for the firewall stuff. So there's no BGP here. So if there's a BGP peering set up between R1 and say VIOS, how does the global internet routing table know that you have let's just say a 38, if I could write 38.1.6.24 no, let's do a 0/27. How does it know how to get there? Because at the end of the day, there needs to be end-to-end reachability. For every link, let's say you've got a router here, a router here, a router here, and a router here. Very similar setup to what we were just troubleshooting. But we still need to understand what's going on. So what's going to end up happening is there's BGP here, and BGP here. This route's been advertised into BGP, right? There's been an advertisement done here, but there's no BGP here. So this would be the customer edge. This would be the provider edge. This would be maybe a provider backbone device, and maybe this is another provider backbone device, or maybe this is, an internet exchange point. If you don't know what that is, basically this is where you would have a big data center with a lot of internet circuits that are terminating inside of it that you have like level 3, AT&T, British Telecom, you name the provider, they all connect into this one location, they run a bunch of fiber circuits to each other, and voila, that's how the internet grows location to location. Well, if you're running BGP between these two circuits here, let's say this is AS100, like what we're running, and this is AS1, this is AS2, and then maybe this is AS21, or whatever that might be. How does this route over here, which this could be, anything that we've got inside. This is our LAN here, and this is the WAN. How does this guy over here, let's say our customer, how does the customer reach our customer edge, our internet edge, if there's no BGP? Well, it's a very, very simple answer. The same way we would advertise this circuit right here, this public address space, into BGP, you do the exact same thing here. You would just create either the provider would simply either redistribute connected for that particular circuit, which would automatically advertise it into BGP, or he would just generate a network statement. Likelihood is if they're handing out a address block to you, well, it's a /29 versus a /27, it really doesn't matter. Let's just assume that you've been given the address block of 38.1.6.0/27. Okay, /27. Well, let's say for instance let's just say that provider has 38.0 or 38.1.0.0/16 is one of its large address blocks. Well, if it just creates a BGP aggregate command, then you're automatically a member that your /27 is already a sub route or subcomponent route of this guy, right? Because how many /27s can you fit inside of a /16? A lot of them. So here, I don't need to sit here and type in a network statement. Maybe I already have an aggregate route that's going to go ahead and call the 38.1.0.0/16 route. By doing that, any customers that I light up with this particular prefix, they're automatically going to get advertised into BGP. So what it means is this circuit right here is automatically going to get allocated, or going to be advertised, into the global BGP table. So your customer is not going to have a problem reaching you. What you need to do is on your equipment is create a 0/0, a default route, pointing towards the provider's IP address, whatever IP address they give you for that particular subnet, whether it's a /29 or a /22, it really makes no difference. There's going to be a default gateway IP address that you're going to have to point your default route towards. Once you determine what that is, you're off to the races. That's all that matters. So that's really what I talk about when I come into play when people ask me, well, how do you know? Like, well, I know because this is what I do for a living. I've done this hundreds of times, and this is something that is very common, and it really has nothing to do with real-world experience. This is core fundamental understanding about how routing works. Because you might get in. Now, I'm obviously studying for my security CCIE eventually. That's my main goal right now, is to clear that. And for those of you that are watching still, I plan on circling back and doing service provider, but to me, I got burnt out on on the SP track. So security seemed like I had done a lot of security work, so I was already pretty well through the all 4 exams for CCNP for security. So it just seemed like a natural transition, and I really enjoy the technologies. So regardless of how it boils down, is I don't pity per se, but I'll feel bad for somebody in a specialization track like security, for instance, that doesn't have a really strong routing and switching background. And the reason I say that is because because there's no prerequisite for a CCIE or a CCNP, or there is for CCNP, but there's no prerequisite for a security CCIE or security data center security, data center CCIE, or whatever. Because there's no prereq, you could pretty much just come out off the street, assuming you've passed the written. You can come in and just knock that out, right? But if you don't have the core fundamentals, I would say at the CCNP route switch level, when you're going into the security, any exam for that matter, at the CCIE level, then you're going to have in my opinion, you potentially could struggle depending on the complexity of the routing that comes into play. Now, I wouldn't say anything that I'm showing you here is terribly advanced. I mean, it's, in my opinion, CCNA, maybe a little CCNP. Nothing crazy, though. Basic redistribution and stuff like that. CCNA level stuff for sure, in my opinion. But if you don't have that core foundation built in and you can't figure out why you can't get that ping to work and you think it's a filtering problem, it had absolutely nothing to do with filtering. And I demonstrated that. Once I got my home router, the physical router, once I got that to learn the routes that were inside of this network right here, well, that was a huge circle. Inside of this network right here, what happened? I have reachability. But it's one of those things where it's like, I kept on talking, reiterating, okay, it's not learning it. Why can't we get there? The route's been propagated. We have a default route. Why can't we get there? In most cases, people would be like, well, it's just something's wrong. Well, if you don't know how to step by step work your way through the problem, or know how to do that, if you don't have that foundation skill, then beyond that, things beyond that particular skill set are going to be difficult for you to work your way through. So that's why I felt like, even though it's not necessarily security focused per se, it's still core foundation. And that's one of the things that I tell my students all the time. It's, you need to lock this crap down now. Lock down the core routing and switching fundamentals. If you don't want to go get your CCNP in routing and switching, don't go get your CCNP in routing and switching. Don't put out the money on the exams if you don't want to. But what you do need to do, and I'm very adamant about this, is you need the fundamentals and need to know how to do this stuff. Because the configurations I'm walking you guys through, they're not that complicated. I mean, we haven't even gotten into anything really complicated yet. There are, like, we could do VRF aware DMVPN with get VPN overlays with PKI. That's going to get a little bit complicated, especially when we're doing VRF aware PKI and stuff like that. It gets in the weeds. But here's the thing. That's a ramp up thing. But that means you need to have a whole bunch of other stuff done. So like basic layer 2 switching, what I'm doing down here with the trunking and the VLANs, and I'm not dealing with, there was a little bit of spinning tree here in the previous video where I had to go in and pull out a port channel and go back to having two individual uplinks because the port channel is messing us up. Things like that, if you don't know how to troubleshoot them or have an idea, okay, well, something's not right here, and I don't know what it is, and you have to kind of zero in on the problem. If you don't have that fundamental understanding of what's actually going on behind the scenes, this is where I would see folks that don't have that foundation struggle. And I would say that if you ask any security CCIE that's out there, and again, my videos and these videos that I'm putting out are not geared specifically to the security CCIE. They're more or less the technologies themselves. But you ask any security CCIE if they believe a CCNA route switch level of understanding is strong enough, I would venture to guess, and I'd be almost willing to put money down that they're going to say you might be able to squeak by with a CCNA in route switch, but you're probably going to be better off with a CCNP. And that's from what I have heard other security CCIEs talk about. That's kind of the interpretation I get from what they've described in the exam that they saw and the complexities. Now, I have not sat for the exam yet. I don't know. But I can tell you right now, there is nothing complicated about this topology that from taking the routing and switching CCIE and having passed that, there is nothing complex about this. In my opinion, there's nothing complicated about this. It's pretty straightforward. I have a router that's running a bunch of connections down to a bunch of locations. Think of that as commodity internet, and you are simply connecting your network devices to a publicly available internet. And then we're going to be routing over it. We're going to do some sort of encrypted connectivity. Site-to-site VPN, remote access VPN, firewalling, all that stuff is going to come into play. So I only get like this when I want you to make sure that issues that I ran into, you may or may not see in the exams. If you do see them in the exams, I want you to understand why they're not working or what the potential 2, 3, 4, 5 steps are that you might need to go through in order to fix them. And that's really what it comes down to. Because, again, back when we were looking at Test 9 and Test 12, we were looking at like, well, I see a default route, but how come I can't get there? Well, just having a default route alone isn't going to be the answer. You need to be able to get beyond the default route and It's like, okay, well, in a router, it should have pointed me towards it should have stopped me at some point in the routing table. It gets you to a certain point and it dies. That's what should have happened if it was all routers and not a firewall. It should have gotten me to the point where the route, in this case here, ASAB1 didn't know where to go. I was like, I don't know. Me no know. Well, in that case, that would have been your jump off point to go, okay, what am I not learning from him? And it just so happens to be that ASAB1 had not advertised any routes. As soon as I advertised those routes, what did we get? Reachability. You're going to hear me harp on that all the time, and that's why I think from a logical perspective, when you're approaching the CCNP, which is what I'm doing right now for security, is get your reachability. IP reachability is necessary before you can start locking it down. And that goes for pretty much any track, whether it's data center, wireless, security, collaboration. I can't connect an IP phone to call manager if my phone can't ping call manager, or a call manager can't ping my phone. If there's not network connectivity, I should say, this way, back and forth, then how am I going to fix the problem? I need to get connectivity there first. First and foremost, reachability is the most important. Then you can start to lock that down and get it squared away. End of rant. So I hope this was informative for you guys. I really wanted to kind of highlight what's going on in terms of the network operations and the details with that, because I think that's really, really important for everybody to understand. And so yeah, I'm actually having a lot of fun going through this. I'm pretty much done with the what do you call it? Yeah, I'm pretty much done with the routing piece. There's a couple of little things that we could go through, like, I don't know, maybe validating routing tables and stuff like that. But not that I don't think that's important. If you look, there's hundreds of other YouTube videos that are out there that you can look at a routing table. As a matter of fact, on my channel here right now, you can look at routing tables. So, and I break down what the administrative distance is, and why the metric value comes up the way that it does, and how the recursion process comes into play. All that stuff has already been talked about. So I'm not going to waste my time doing that when it's already been said. So we're going to move into the next video. I'm actually going to do an ASDM breakdown. So I'll be walking you guys through how to navigate the ASDM and stuff like that. But beyond that, guys, that's pretty much what I wanted to cover in this video. You guys have been awesome. Thanks so much for hanging out with me. And until next time, take it easy.